My name is Tom Lokhorst. I work at Q42 and I want to talk about the Rijksmuseum ArtViewer. So this is not a very generic talk, but instead very specific. And unless you're also building an ArtViewer, I don't know if you can take away any concrete learnings, but I hope it will be enjoyable. As I said, I work at Q42, and what we do, we're a project agency, and we build apps and websites and virtual reality things for clients. So some of our clients are KLM, Philips, and also the Rijksmuseum. And 5 years ago, we built this. This is the Rijksmuseum.nl website. And at the time when it launched, it was very innovative because it had, instead of where other museums have little thumbnails and you click on them and you get a flash player with a watermark and stuff. Here, when you click on an image, you see it full screen. The entire experience is the image, and you can even download the image at high resolution under a Creative Commons license and do things with those images, print them on your wallpaper in your house, on your bicycle, on your dress, whatever you want. All the images are available for free. So that was very special in the world of museums. And the website won a lot of prizes, which we're happy with. But then a couple of years later, Rijksmuseum came to us again and asked for an app. So that's what we built. This is the Rijksmuseum app, yes, and this is the design. It's supposed to look like that. Let me let me show you. Yeah, look here. This should be visible. Yes, okay. So this is should show it from this. Whoops. I have to do this upside down. Okay. Rijksmuseum. So, and what you can do in the app is two things. If you're in the museum, you can visit, do tours, walk around in the museum, and it will guide you through from artwork to artwork, where you can do, for example, the highlights tour and listen to audio descriptions about interesting details. And if you're at home, you can use the app as well. That's what I wanted to show you. At home or on the go. And here you can see the Rijksstudio, as it's known. And this shows you a stream of collections and artworks. So this is sort of like a Twitter stream or an Instagram feed. And you can just browse through them. And if you see something you like, then click on it and then browse through that and see all the artworks. And then you can zoom in to something to look at what it is. So this is really, yeah. So each time I look at the app, it's different. This I'm going to look for something else. Here, this is nicer. So this is a little angel boy, and you can zoom in and look at all the details. He's not picking. It's silence. This is what is this called? Seated Cupid. So yeah, and this is what I want to talk about. This single component. This is called the ArtViewer, where you can zoom into a piece of art at really far. So this one, let's look at this. This is Rembrandt. And you can see his nose real close. Look at his ear. Yeah, so this is what I want to talk about. I don't want to print it. So the three things I want to talk about is what are the user interactions with this component, the ArtViewer, what do you have to do to implement this, and what is the deal with tiles, because that's what you need to to get the zooming behavior. And these are the top seven, I think, topics which I'll go through. And the first one is scrolling. So if you want to build something like a zooming scroll view, you can use a scroll view, an iOS scroll view. So you start with an empty app, and to that you add a scroll view and a nested image view. And now you can already pan left and right and up and down, because that's what a scroll view does for you. And what you can also do is just set the image size to be something really, really big. So even though it's if you use a small image, you can still stretch it to 14,000 pixels wide, and iOS will handle that just fine. And then the image just gets very blurry. But it will work. And then you can make it zoomable by setting its minimum and maximum scale. So those just fall off the edge. But it says minimum and maximum scale, and implement view for zooming in scroll view, and then you can zoom on an image. And that's when you have that, you're already halfway there. So this is an iPhone 4S, and it works on that. It doesn't need a lot of, it works just fine. It's iOS 9. So if we look at this is the scroll view, and we can zoom out. And this is the 14,000 pixel wide image, but it's just a stretched image. So if we zoom into some part of it, you can see that it gets really, really blurry, because it's a small image that gets stretched to 14,000 pixels. But now we already have a lot of nice behavior. So you're already seeing the scrolling and deceleration thing from iOS. Can zoom in and out. It has the nice bounce effects at the edges. So this is already a pretty good experience just by using a scroll view. And then if we make it really small, you can see I set the minimum size to 1%, so 0.01, and then you get this, a really tiny image. Yes, so that was demo 0. First thing we want to do after that is center the image to have it be to have it fit to the screen and be in the center, not at the top left as a very little image. And to do that, we need to set the zoom scale. We have to calculate that to figure out for this size image, for this size phone, at what's your default zoom scale. And we can also set the content inset, which makes sure the content is moved down a bit. So this is not adding to the content, but it's moving the content down to whatever number we need to have it be centered. And an important thing to remember here is then when you're rotating your phone, your bounce of your scroll view change. So now you have to recalculate those numbers, and now the content inset also has to add space on the left and on the right instead of the top and the bottom, because the centering, the phone has different dimensions. And rotating a phone is one example where the size of the ArtViewer changes. Another one, if you're on an iPad app, there you can go in split screen and really resize the size of your application. So that's another example where everything has to be recalculated. So those are demos 1 and 2. Let's see 1. So this here you see it's a bit dark, but it's centered now. Let's see if I can make it a bit brighter. Yeah, sort of works. So here the image is centered, and when I rotate, it gets centered again. But it needs to change the zoom scale, because the image needs to be bigger when it's in landscape than when it's in portrait. Yes, and what I want to have is to be able, yeah, that was the one thing. What I want, the next thing I want to talk about is zooming when I double tap, because that's not something that's provided by default, so we have to implement that ourselves. So zooming. Zooming is actually, recognizing the tabs isn't that hard. We can create a TapGestureRecognizer, configure it to take 2 tabs and set the function we want to be called, and assign the gesture recognizer to the scroll view. And now whenever we double tap on the scroll view, this method gets called. We can also zoom out by tapping. I'm curious, who knows how to zoom out by tapping? What gesture you need to do to zoom out? Pinching, yeah, pinching is the obvious one, pinch in and out. But on iOS, there's also a way to tap to zoom out. 2-finger tap, yes. So that's not something I knew before working on this, but apparently in maps, when you double tap with 1 finger, you zoom in, and when you single tap with 2 fingers, you zoom out. And there are people who use this. So if you do, you can. It's easy enough to create. Instead of setting the number of taps required, we set the number of touches required, and then you can zoom out by tapping with 2 fingers. So, in contrast to, for example, the pictures application, the photos application on your phone, when you're double tapping, you're zooming in to the complete image, and then you double tap again and you zoom out to have the image fit on your screen. But here we don't want to zoom so far because there's a lot of levels of detail and we just want to zoom in a little bit, and then you double tap again and zoom in a little bit again. Otherwise you end up at a very close by to the image if you completely zoom in, and that's not what you want. So in this way it works more like a maps application, where you zoom in a bit and then zoom out again and zoom in a bit on some other part of the image. And to implement that, we use from maps the concept of zoom levels. And a zoom level works like this. The original image, the 14,000 pixel wide image, is called zoom level 0. And then when you zoom out a bit, when you're halving the size, that's called zoom level 1. So each time you zoom out and you have twice as much information on the screen, that's another zoom level. So that's 1, 2, 3, 4, and so on. But this is not how iOS works with zooming. iOS instead uses scale, where the original image is at scale 1, and when you're zooming out to half the size, you're at scale 0.5, and then a quarter, and then an eighth, and so on. So this is a table we need to map between. And the scale is what iOS uses all the time, and the level is what we want to be working with, because that's a lot easier to deal with. And then you go to some colleagues who know math, and then they come up with this nice graph. So on the left-hand side is the scale from iOS 1 to 0, and on the right-hand side is the level 0 to infinity, depending on how far you want to, how many zoom levels you have. And now, when we want to implement the double tap, the scroll view is at some scale, and we want to go to some other scale, and we need to figure out how far that is. For example, you're at scale 0.162, and you're double tapping, where do you want to go to? We first convert that to a zoom level. In this case, that's 2.63. And then we can see that we have 2 levels of detail. We can go to the most zoomed in version, that is level 0, in 2 steps, because there's 2 more levels of details at level 1 and at level 0. So in this example, the first double tap will take us halfway there, which is 1.3, and then we can convert that number back and go to 0.4. So that's a lot of calculation to figure out from 1.62 double tap go to 0.4. And we can do this for any level what you're at, and for either zooming in or zooming out. So whenever you want to do something like this, it helps to create a struct to encapsulate all that logic. So this really represents the concept of a zoom level, where you can go from either a level to a scale or from a scale to a level. And then implementing the actual zooming, the calculation is pretty easy. You take the level, divide it by the floor of the level, because you want, in the example where you start at 2.6, you want to zoom in 2 steps. So that's 2.6 minus 1.3, and that gives us a new zoom level. And that way we end up at exactly 0 at the end. So we're not having some remainder part there. You can, in 2 steps, jump from directly to the most zoomed in version. And that I can show you. So let's first look at the version without, where we just naively double the zoom scale whenever you double tap. And that looks like this. Zoom in, zoom in. So this looks pretty nice. You know, whenever you double tap, you zoom in. But this part is a bit weird. So we zoom in, zoom in, zoom in, zoom in. And now here we're almost at 0, but not quite. And then you have this little tiny jump, which doesn't add any value really. It's just a rounding error. And instead, if we use the zoom levels, now whenever we exactly end up at the most highest level of detail. And now we're there. So that's a real nice way for doing zooming. And we need this for tiling as well.
So basically, you zoom more than the factor 2 that is in the original.
Yes. So in this example, yeah, there are 2 steps. We're starting here, and that means there's 2 steps. If you would have started here, that means there would have been 3 steps. So then the first one would have been somewhere here, second one somewhere here, and then the final one over there.
What has defined this yellow curve for you guys then? Because to me it's just a random curve that for some reason probably it looks nice or something.
That is
it's a log.
This scale.
Yeah, no.
Simple calculation. Log.
Yeah.
But why not linear?
A half quadraat. Well, it doesn't look nice.
That's. I'll get to that when I get to tiling, but each level of details simply doubles the previous level. So this is or halving it really. This is half, 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 and yeah, and you can continue doing that. So what we call a level is simply removing half of the quality, and that leads to this curve. Let's see. Resizing, I think I'll skip. It's fun. I'll show you the animations. So when you're rotating your image, you can either choose to have it be fit to the screen, where you have borders on both sides, and when you rotate, it will still be fit to the screen, or you can have it fill the entire size of the screen, but then you need to clip, and then an editorial can decide where the center of the screen is. So you're not arbitrarily clipping some part of the screen, but an editor can decide which is the center of the screen. And that way, that one part will be kept in the center. And the final mode you can be in is to be zoomed in. So here we're zoomed in to some center point.
So each artwork has its own clipping boundaries?
Yes. So that's in particularly for if you have a portrait image, where you have a portrait of some person and you're looking at a landscape phone, if you don't have any editorial content, then it would be this, and that looks really weird. So editors decide the eyes mostly, and then this part will be centered. And now tiling. So the reason we need tiling is to find the optimum between these three aspects. We don't want to download too much information because the user is downloading all images all the time, and that simply would take too long. We also don't want to have too big of images because that wouldn't fit on low-end devices, and also it's not really useful to have very big images if you're not only displaying a small part of it. But also we want good image quality, so we can't simply have a very small image that would be of small size and small pixels, but then the image quality would be bad. So to solve that, we have tiling. This is the source image we're working with, the night watch. It's 14,000 pixels wide by 11,000 pixels high, and it's about the JPEG is about 37 megabytes. And the original artwork in the Rijksmuseum is 4.5 meters wide, so that's about 3 pixels per millimeter. So that's a lot of pixels. And what's interesting about this is, so this is 14,000 pixels wide. My phone is 1100 pixels wide, 1125. So I can't display this original image on my phone, but also if you have a 5K display, that can't display this image. I think if you have a 10K display, it couldn't display this image. There isn't really a consumer-grade display that could display this whole image. So what is the point of having this image? The point is that you can zoom into a single part of it. So if you're looking at just this part, then this image would be very useful to have. So that's where the tiling comes in. We cut up the image in a lot of tiles. Each tile is 512 by 512 pixels, about 25 kilobytes. And now if you're zooming into this center, we download just this little 25 kilobyte tile, and you can see the full quality of the image. And because your phone is restricted to a certain size, you can't see all the other parts because they don't fit on your screen. So we don't need to download those. So yeah, this is level 0 of the image, 14,000 pixels wide. That leads, if we have pieces of 512 pixels, that leads to 23 columns, 23 rows, 28 columns in a total of 644. And these numbers are really the result of the source image. So if it's not dependent on the phone you're displaying this on or whatever device you're displaying this on, it's dependent on the source image that determines how many columns and rows there are. So these tiles are great if you're zoomed in all the way and want to look at the most finest detail. Then we pick just the tiles that are on screen and download those. But if you're zoomed halfway out, then we don't need all those detailed tiles. Then we can use less detailed tiles. So that's the second level up, level 1. We created this by first halving the image to just 7,000 pixels wide. And now we again cut those up in pieces of 512 by 512 pixels, and we need a lot less columns and rows to display or to cut up the image. So if you're at a slightly less zoomed in version, then we can use these images. If you're even further zoomed out of the image, this process continues. We just use these tiles. So now the image is only 3,000 pixels wide. If I want to show the entire night watch on my phone, on my iPhone 10 with 1125 pixels, this would be too tall, so or too wide. So because this is 3000 pixels, that's too many pixels. So this wouldn't be the level to show. For an iPhone 10, we need this level, level 3. That's still too wide, but level 4 is too small. Level 4 is 800 pixels wide. That if I were to show this on an iPhone 10, then I'd have to stretch out the images, making them more blurry, so that wouldn't look good. So for an iPhone 10, we need level 3. For an iPhone 4, that is just 640 pixels wide, we can use this image. So then it starts to depend on the hardware you have, which level you want to display. So this is level 4, just 4 tiles. And finally, there's level 5, which is 1 tile of less than 512 pixels, just whatever remains. So these are all the levels of this image. And the reason there are 6 levels is because the source image was that wide. If we had a wider source image, we'd need 7 levels or 8 levels. So that's dependent on the size of the source image. Okay, so if we want to implement this, this is where things get fun. Luckily, iOS has something built for that, which is called the CA tiled layer. So each view on iOS has a backing core animation layer, and one of those is the tiled layer. And the tiled layer has support for this concept of having different tiles, first of all, at different positions in your view, and also using other tiles for other zoom levels. So the CA tiled layer already does a lot of the logic for figuring out, so this is how we use it. We have a tiling view inside a scroll view next to the image view. And the CA tiled layer will figure out how far the scroll view is zoomed in at what level that tiles needs to be at. So this is how we can implement that. Create a subclass of UI view and override the layer class property and say that this view is backed by a CA tiled layer. And CA tiled layer has 2 properties we need to set: tile size and levels of detail. So the tile size is 512 by 512 in our example, and the levels of details is 6. And then the layer will start calling us back on the draw function. So we implement the draw function, and then the layer will say for this rectangle, start giving me tiles, start drawing tiles, and it will do that on 2 background threads. So your your main thread isn't blocked. On 2 background threads, you need to start rendering images on the correct size. So in our application, this is how we implement that. We have our data source, and that says for each image we want to display, this is the tile size, and this many levels of details are there. And then we provide an image for each row, column, and level. Let's see, so let's demo again. 6, 7, and 8 apparently. Here I'm not showing images, instead I'm showing a color. Whenever the tiled layer asks me for a tile, I just draw a rectangle of a random color at that position. So here you can see the behavior of the way the tiled layer behaves. So here it needs to show 4 images at this size. Here it can show a single tile. And if I'm zooming in, it needs to create new tiles with new information. So whenever the colors change, it has decided it needs a new level of detail. And if I zoom in and out, you can see that even though I randomly choose a color, I keep seeing the same color because the tiled layer caches the result. So it only it remembers what tile was previously rendered. And this really shows how the tiled layer does a lot of work. So this is the basics, and then we can start giving back images. Hard to read upside down. 7. And now I've drawn borders around each image so you can see it. So now I'm rendering the correct image. So now when I zoom in, it's really, really sharp because it's rendering a single tile here. It's a single image that's at the quality we need for this zoom level. And if I now pan around, it will download other tiles, or not download, it will show you other tiles. So all of this is really, really sharp. And at any single point in time, I'm just here showing 4 tiles. So that's not that many tiles to show. And even if I zoom out a bit, here I'm only showing 12 tiles at a time. So there's not a lot of things that need to be shown. Each one is 25 kilobytes. However, these images are synchronous. They're all on the phone. This is 37 megabytes of images that are on the phone, but the way we're using it, we need to download those images from the internet. And the default implementation would be to, whenever an image is requested, start the download, which is asynchronous. It takes a little bit. And then when that download comes back, save that image in a cache and invalidate the layer and say, re-render this part, I now have an image available. And that would look like this. Here you can see images being downloaded. So at first it's black because there's nothing there. And then whenever we zoom in, information, yeah, you can see things being downloaded. And this is what a lot of websites and mapping apps look like, and that's really unfortunate. It just looks bad. So that's not what we want. We want something better. And that's the final part, which is the async downloader. So say we want this image, and that's 25 kilobytes and takes maybe a second to download. And we need to show this on the screen. So we could, in the meantime, show something black there, but that's not nice. Instead, we can look at our cache, because we've already cached a lot of other images, and see if there's something we can use. And in fact, one level up, at level 1, there's another tile which also contains this image. So what we can do is cut out the right-hand side of that image, stretch it out, and then we have something we can use as a placeholder. It would be a bit blurry because it's a stretched out image, but it works fine as a placeholder for that second it takes to download the new tile. And then when the new tile becomes available, we crossfade to the better version. So that's what we could do as a placeholder. But what if we don't have this tile? Well, there's another tile we could use, which is, again, one level up. Because even there, we can cut out a little part of it, stretch that out 4 times, and use that one as a placeholder for the original image we needed. And we can continue doing that, because at each level, there is the image. Even in this really, really small image, the thing we need is in there somewhere. We can cut that out, stretch it out a whole lot, and use that one as a placeholder. So that's what this would look like. This is the really blurry version that's stretched out a lot. And then whenever we get a sharper image, they simply start filling in and crossfading and becoming sharper and sharper. So this is the pattern. Whenever we need an image, we simply look through our cache, figuring out if we have something that can act as a placeholder. And if you make sure you start, whenever you start this tiling image viewer, with at least this image in cache, even though it's really low res, then whatever part you're zooming in, you can always show something, and it will simply progressively get sharper and sharper. Yes, so that is this pattern. Always display an image from cache, fall back to higher zoom levels, and load the cache in reverse order. So start with downloading this image, then download that one, then that one, then that one, then that one, then that one. So even though if we need this one, we don't download that first, but we first download this one because that one is useful for 4 other images. Yes, so these are the final 2 demos. What I've done here is color the images a different color that are used as a fallback image. So the green ones you see here are images that are not the original one that is requested, but some stretched out image. And now whenever I zoom in, you can see it's downloading, it's figuring out reusing other images as placeholders while it's loading a better version. So now you can, even when you're zoomed in, just pan around in the image, and it already always has something from cache that it can use as a placeholder while it's downloading better and better versions. So if we look at the final version, you can't really see this on this webcam. You need to see it on an actual device, but here it's hardly noticeable that it's actually doing the downloading. It's simply crossfading all the time. Now it's downloading a lot of images, but you can't really see it. Whenever you're focusing on something, it's almost already done downloading a better and better version of it. So I think, yes, that was it. So thanks for your attention. Any questions? Yes.
So you gave every tile a different number in order to look in the cache for the same image?
Every tile has its position is the row number, the column number at a certain zoom level. So that's what makes the tile unique.
Okay, but is there also a link between different zoom levels, because you have to find the nose
yes.
of the same guy in the next
so that's at levels, the top left one is at level 0, it's 11 row 11 column 13. 1 level up, you just halve those. So that is 4 by 6. You can simply, by looking at the original row and column number at any zoom level, you can calculate what row and column it must be in that level, and then also figure out if it's in the right-hand side of or the left-hand side of that level. And that's what you can use to cut out a little part of it. Yes?
You very casually said that the tiles are a different size around the edges.
Yes.
How painful is it, in fact, to deal with that edge case?
Not that hard. It's really I think maybe it's a intersection function on the CG-Rect. You just you shouldn't forget it, because then stuff gets stretched out to a wrong size. But it's not that hard to deal with. I sometimes have a tile which is just 1 pixel high, and that happens sometimes, but yeah, it's not that difficult to deal with. No, but yes?
So the cutting out on higher levels for the less detail, that's all on device, let's say. So you download the lesser detail version, then you cut it out on device immediately, and yes. That's what you show.
Yes. Okay. And this was on an iPhone 4S on iOS 9, and it works fine. And
do you really cut out the image and create a new structure in memory, or Is it really say I pick this this bigger tile and I only display this part, that you can actually indicate this is the viewport on this tile?
I do not remember.
Just cutting it out seems a bit wasteful.
I think you blow up the image.
Yeah, that you just say these coordinates.
Well, it's using a sliced image 4, so it's apparently cutting it out. Maybe it can be smarter, but what it needs to do is render it to a CG context. So probably it could just render the part of the image directly to there.
Maybe that's not on the GPU, so you don't notice it.
Yeah, I've never seen performance problems with doing it this way.
But you have to do a lot of core graphics programming for this, like creating beginning context, ending context, that kind of stuff?
Yes, but not a lot. Yeah.
No, because you know you double the picture every time.
Yes.
But this is basically what MapKit also uses, right?
Yes, but the difference is that especially the version that uses satellite photos, they use different photos at different levels. So sometimes you use satellite photos, but if you're zooming in, they're using photos from planes. So you can see it changes whenever you change levels. And this is all the same image, so it looks better.
So and the image from the night watch is of course different from the other pictures in the museum, which
yes.
are also in there and zoomable, so you had to calculate the exact same stuff for every separate image. You have to make separate zoom levels for every image in the app.
We have to create the, how do I jump to Navigator? This is for every image. So yeah, so there are different numbers of levels per image. But that's all there is. The only thing actually we need to know is the original size of the image, because then, having said, then you can calculate all these other numbers from those.
The night watch is the biggest image in the app, or?
Yeah.
Yes. What makes it a good example. But there are certainly bigger pictures on the internet, but this is the biggest one we have on in the Rijksmuseum app.
I believe they even cut off pieces.
Of the original night watch, there is, yes. It used to be bigger.
No, it didn't fit in the room, so they cut
yeah.
it.
Yeah, they couldn't get it into the room, right?
No.
No, they wanted to fit it between two posts, so they just cut off a piece of in the 18th century somewhere.
It's just wallpaper. Come on, what are you talking about?
This is fine. In China, they actually stamp it and then add their own poems.
Any other questions?
Yeah.
Yes.
So Apple did a pretty awesome job at tiled layer. Did you guys get it to work on Android as well?
Yes, you can download the Android app. It's a bit, yeah. There we don't have the tiled layer, and we're using some third-party library, and it's a bit uses a bit less of this, but the same principles, and also there you can zoom in and not see the black tiles in the meantime. Okay, thank you.